Hello, everyone. Welcome to Dev 327, Beyond Basics, Advanced Infrastructure as Code Programming on AWS. This is Luis Colon. He is one of the senior dev advocates for AWS CloudFormation. And I'm Chuck Meyer. I'm the other dev advocate, senior dev advocate for AWS CloudFormation. Welcome. I think we might be the last thing standing between you and the replay party tonight. So we'll try and keep
Hang in there, people. Hang in there.
Yeah. So we will, we're going to take the whole time. Please make sure you eat something too, right? Stay hydrated, all that good stuff. We're almost done with the week, but we're not quite. So what are we talking about today? Today we're going to be talking about ways to extend CloudFormation, ways to sort of inject additional programmatic aspects into it. We're going to be talking a lot about sort of comparing mechanisms that extend the intrinsic declarative nature of CloudFormation and ways that extend by layering on imperative on top. So we're going to be talking a lot about sort of the differences between declarative and imperative coding styles, but within the context of infrastructure code, and specifically within the context of CloudFormation. Okay. Once we've gone through that, kind of level set everybody, I'm going to start drilling into a few examples of a relatively new CloudFormation feature called macros. And we're going to look at some specific examples of that and using that as a mechanism to sort of extend beyond basic YAML and JSON. And then I'm going to hand off to Luis. And Luis is going to start talking a little bit more about layering imperative on top of CloudFormation and some sort of cool things that you can do there using some old familiar tools and some newer stuff that's coming out as well. Okay. So that's sort of the basic agenda for this talk. I'm going to start here with the basics, though. And just a heads up, I guess, so who here is a CloudFormation user? We'll start there, right? Okay, existing CloudFormation users. Who's here to learn more about infrastructure as code in CloudFormation? Okay, fair enough. For those that use CloudFormation, who are the folks that are just writing JSON YAML? Okay. And who are layering other tools on top of that at this point already? Okay, so there's some folks here that are already sort of down that journey. Well, we're going to be doing some comparing and contrasting along the way, and there might be some new ideas here. There's definitely some new tools, okay? But just a level set for everyone, because we do have kind of every range, just a little bit about the difference between declarative and imperative. So declarative programming is describing the end state that you want. These are the things I want, and then sort of letting the tool or the code figure out how to get there, right? So I want this thing, I need these particular properties of that thing, and I need to make sure that it happens in sort of a nice idempotent way. All of that stuff, you don't really worry about it, you kind of let the tools do it for you. And this is sort of a mode that comes from the bold tradition of configuration management tools, right? This is something that you often see with things like a chef recipe or an Ansible play. And it's also something that we will talk about a lot with CloudFormation as well. Now, the kind of the opposition to a declarative model would be more of an imperative model, where you're sort of more focused on the verbs, the actions. These are the things that I want to do, right? And this is more familiar for folks that program in your Turing complete languages, your sort of higher level languages, writing applications, things like that. So why would you want one mode over another? Well, declarative, because you're describing what you want and you don't really have to think as much about how to get there, it tends to be a little bit easier to sort of jump into often. You don't really have to understand those idiosyncrasies, a lot of sort of the error checking and stuff you're hoping that the tool will take care of on your behalf. But you lose some of the things that you think of when you think about code. Declarative doesn't tend to loop. It tends to be specific in what you are describing. So in a lot of cases, you wouldn't necessarily be saying, this thing X number of times or whatever, but the flip side of that means that you're wearing out your Control-C and your Control-V on your keyboard as you kind of dump the same thing in over and over again. Now, imperative is really comfortable for folks that have been doing it for a long time. If you're a developer, this is kind of where you live. But if you're not, it can be a little daunting to kind of come into and learn all of the idiosyncrasies and nuances of sort of doing imperative programming. So there's an expectation that you are comfortable in that language. And by getting that, you get all the flexibility of that language, right? Whether it's inheritance or object-oriented or global variables or libraries, complex logical operators. All of that stuff comes out of an imperative model. Okay. So what is CloudFormation, right? CloudFormation is, in its roots and its bones, tied to a declarative model. 7+ years ago, when it was first designed, the intention was you describe your infrastructure in a flat file in JSON at the time, and now more commonly in YAML. You describe exactly what you want. And we're not really telling CloudFormation how to get there. We're not even necessarily telling CloudFormation the exact order of things. We're kind of going to allow CloudFormation to handle that for us, to understand when there are interdependencies between resources. We can layer that in if we need to, but for the most part, CloudFormation sort of understands that and takes care of it for us, which is pretty cool, right? So we've got a little template here talking about our auto-scaling group, and we tell it that our desired capacity for this auto-scaling group is 4. And CloudFormation knows what it needs to do to go and call the appropriate APIs to provision that auto-scaling group. Then we tell CloudFormation, oh, actually, I changed my mind. I want that to be 6. And CloudFormation can go and it can evaluate sort of the space it's in and sort of do the right thing from an API perspective there to get you where you need to be. There is a little bit of sort of imperative capability that's been layered into CloudFormation through the years. Sort of the oldest example of this is user data, right? So EC2 instances allow you to inject in imperative code to run on those instances. And CloudFormation supports this. So CloudFormation, you can actually write scripts. You can write sort of imperative shell scripts or Python or what have you, and that will execute within the context of the EC2 instance. And we also have layered in these things called intrinsic functions, which allow you to sort of do some specialized coding type things within your template itself. And this includes some logic operators. So there's a concept of conditionals, and you can do Booleans using our fn-if inherent function. So you can kind of layer in a little bit of this, but it's definitely not by any stretch of the imagination a Turing-complete language or something that you would write an executable program in. It's kind of just enough to get by. So there's opportunities here to sort of take CloudFormation and expand on top of what's inherently natively available in your JSON and YAML files by layering in sort of these additional tools. Some of them are ours, some of them are coming from third parties. And they kind of fall into 2 categories. Categories where the functional code component is still hidden behind the declarative nature of CloudFormation, and then tools where you're sort of wrapping that declarative code in something, a larger sort of imperative language. Maybe you're even generating that code from that imperative language. And so we're going to kind of talk about both sides of the equation here. So declarative, obviously what falls into that category is that basic JSON and YAML that we've been talking about. And another feature that's sort of newer to CloudFormation is this concept of a transform. Right? So a transform is an opportunity for CloudFormation to execute some code behind the scenes in a Lambda function that manipulates that flat file JSON or YAML that you're submitting in some sort of way. And when we first launched that capability, we didn't really give you access to it. We sort of wrote our own, and we released 2 to start with. The include transform, which allows you to kind of pull in another piece of JSON or YAML and inject it into your template, and the SAM, the serverless application model, which is a nice abstraction for folks that are doing serverless development rather than kind of writing a lot of the connective tissue code that you need to sort of associate a bunch of things together. SAM can kind of take care of that and abstract it for you. Now, more recently, we've allowed you to sort of write your own transforms. We call that macros. It's the exact same piece of technology under the covers as SAM or includes. And macros allow you to do the same thing. Some of these sort of more functional programming mechanisms with iteration and conditionals and all of that stuff, you can actually kind of run under the covers in a Lambda function to manipulate your template, generate a new one, generate a change set that you can then submit instead of that initial template. And there are lots of kind of reasons to do this. We're going to look at several examples and kind of maybe get some ideas about things that you might want to either steal from these examples, or go and write your own kind of based on them. Now, when I get to the macros part, all of those examples, they're going to be available, they are available in GitHub. And we'll make sure that you have access to them, again, if you want to steal or if you want to just look at and kind of think about. And then sort of the granddaddy of all of this stuff is taking a CloudFormation template and layering another templating language on top of it, templating your template. This was often done with Mustache in the past. I've done it with Jinja 2, basically passing it to something like Ansible that can then extract out that templating component, do whatever it needs to do, and then leave you with a flat CloudFormation template that then can be passed to the service. Now, on the imperative side, there's a lot of stuff that's been around for a while. Any Troposphere users here? Okay, we've got a few Troposphere users. Troposphere is a DSL for Python, right? It's a language binding that essentially allows you to write sort of Pythonic code that is one-for-one mapped to sort of the resource model of CloudFormation, so that you're just writing Python. And then at the end of the day, you execute that, and it generates the CloudFormation template under the covers for you. Similar things are available in other languages. Sparkle Formation is a popular one for Ruby. Do we have any Sparkle Formation users here? Okay. And then some AWS team members actually wrote language binding for Golang called GoFormation. And it goes on and on. These things have kind of been around for a while. The things about things like Troposphere and Sparkle Formation that impress me is the length of time that they've been around. They've got really strong communities behind them, and very dedicated people sort of at the tops. They're both open source, but at the tops of those repos that make them sort of ready for enterprise use in a way that maybe some of the newer ones, you might want to give them a little bit more time to settle down. The newest player in this space is very different. This is the Cloud Development Kit. And this was actually written by our colleagues in the SDK team. So they're the folks that bring you the CLI and a lot of the APIs and SDKs like Bodo and all of that stuff. This is a tool that they've written that is kind of much larger than just a straight up DSL. It has a lot more ambition as far as what it can do to accelerate programmers' ability to write imperative code that generates CloudFormation behind the scenes. Luis is going to talk about that quite a bit more in his part of this talk. But the important thing about it is, regardless of which side of this equation you're sort of working on, all of these tools at the end of the day are generating that flat JSON or YAML file. That is what is the kind of the fundamental thing that CloudFormation needs to be able to do its job. Okay, so I'm going to get in a little further on macros at this point. And we're going to show some examples here. But first, just a little bit about what macros are. I kind of talked about this earlier. But macros are an opportunity to sort of write short functional programs that live in Lambda that can be triggered by your CloudFormation code. So the way they work, well, what they do for you is they sort of allow you to layer in imperatives behind the scenes. So you can do things like do that iteration or counts that so many people are clamoring for. Like, I understand it's it really decreases the amount of CloudFormation that you have to write, of JSON and YAML that you have to write. But there are other things you can do here too, right? You can do introspection. You can look at those files and make decisions about whether or not you're comfortable with the way that the author has written them. Things like encryption, right? Things like that, governance, best practices, things like that. You can actually bake that in before anything is even provisioned within CloudFormation. And they're easy to share and reuse. So as we'll see when we start getting into the examples, macros are, in fact, resources within AWS. When you provision a macro, it receives an ARN, and you can leverage that macro within any template within that account, within that region, I believe. So it's something that once you've written this code, your end users can consume it without having to know about it or think about it, right? As long as it's well documented and they're aware that it exists within that account. So that's kind of cool, right? That's sort of one of these interesting features of it when we're thinking about that sort of ease of use of declarative versus imperative code. If your end users are not, dyed-in-the-wool developers, this gives them the ability to use those types of functionality without having to sort of go and pick up the code and sort of learn how to do all of that themselves. And the other cool thing about macros is that they are consuming AWS primitives. They're Lambda functions. So we're not doing anything new and clever here. This is really just taking the building blocks that we have and stitching them together in a way that sort of is sensible. Okay, so drilling into some examples here. We've kind of selected these. Again, these are all sort of examples that exist in our AWS CloudFormation templates repository, which lives in the AWS Labs organization. We're going to have some links at the end. So but the bottom line is these are all examples that you can kind of go and pull down and play with right now. We're going to start with the iterator one, because that's the one we always hear. And then we're going to look at some that execute code. We're going to look at some sort of building up of intrinsic functions. And then we're going to get into some kind of cool, interesting stuff around extending the functionality of CloudFormation by leveraging macros kind of running during this pre-processing phase. The first one we're going to talk about is the iterator example. And I apologize, I know this code's a little small, but the reason I put it here the way it is this is it. This is all the code. So there's not a lot of it. We're not talking about writing long, complex programs. We're talking about writing small helper functions that can be layered on top of each other. You're not limited to a single macro for a template. You can use multiple macros. So there's no reason to write one macro to rule them all. You can actually kind of build your snippets based on their function. This one, it kind of has three main parts to it. Way down at the bottom, you can see there's the sort of the boilerplate, what you would expect from a Lambda with your handler. At the top, you can see us sort of processing the template. So what happens when you trigger a macro? Well, if you trigger sort of at the top of your template, then what happens is when we get to the macro receives the entire template as an object when in your language of choice. So my language of choice tends to be Python, so I get a dict, and I can kind of iterate through that. I can pick out the pieces that I need. I can make informed decisions. And then that's that middle part there, right? That's actually where the logic is, where we're actually saying, oh, I found something that I need to act upon, and now let me go ahead and execute against it. This is deploying a macro. Like I said, a macro is a resource. It can be provisioned into your account. It can be consumed by multiple users. And this is just simply a way of sort of taking that Lambda function and sort of mapping it to whatever abstracted name that you want to leverage for your particular function. So in this case, we're saying we have a serverless, we have a macro called count, right, for our iterator. We're going to pass in as a parameter, get added parameter, the Lambda function that we've defined. And then we're going to leverage the serverless application model, which is, of course, a macro, right? So we're using a macro to build a macro here to actually define the Lambda in an abstracted way. So again, super simple, not a lot of code here. This gets it up into your account and ready to use. Now, this is what it looks like to the end user. So they're writing code. The first thing they do is they do need to add sort of this additional component, which is saying, hey, I've got a transform, and it's this count transform. And we know what count means because we've already registered it as a macro within the account. And now we just define our resources like we always do, but we have the ability to put in this sort of arbitrary new attribute of our resource called count. So here we've added it to an S3 bucket, and we're saying that we actually want 3 of those. And we're adding it to our autoscaling, or I'm sorry, to our SQS queue here, and we're saying we want 2 of those. Now what happens is when CloudFormation goes in to process that template, it will see that count, it recognizes that that's registered to that particular macro, and it will go execute that code, generate the larger version with the 3 or the 2 resources, and then build a change set around that with that expanded version. Okay, so sort of moving into a more complex example. This one's kind of clever, and I have a security background, so clever but also a little bit horrifying, to be perfectly honest. This is a macro that executes arbitrary Python behind the scenes for your CloudFormation template, okay? So what you can see is here on the left, we've got a template that actually has the macro already embedded into it. And we've written in orange there's a little bit of Python. And what this is doing is it's trying to essentially expand out a parameter into multiple key value pairs, right? So this is probably written by someone, I'm going to guess using nested stacks, who maybe came up against the parameter limit and is trying to look for ways to sort of consolidate their parameters. And so what they've done is they've said, okay, I'm going to just take all my tags and eat one parameter for that, and then use a macro to expand that out. And now my macro can go and put the appropriate tags on all of my resources without me having to burn through a bunch of parameters to get all that information into CloudFormation. Okay? Again, not a lot of code on the backside for this. The one thing that I think is particularly interesting, is this the one? No, this isn't the one. We'll talk about what's particularly interesting in a minute. But what we will talk about on this one is what's particularly horrifying, right? Is the fact that I've got a Lambda running in the backside that's just running arbitrary Python code, which is a little terrifying. But keep in mind, what are we feeding into this thing? Well, the only information it's getting is my CloudFormation template itself. But still, if you're going to do something like this, I'd probably put some guardrails on it, unless you're very, very comfortable that. Say again, sorry? Oh, sorry, I thought I heard something there. So anyway, I would be, unless you're very, very comfortable with the users of this thing. So talking in terms of guardrails, kind of moving into sort of the next function here. This is another big ask, right? CloudFormation, because it's not a Turing-complete language, we don't have string manipulation. We don't have the ability to do uppercase and lowercase. We don't have math functions. Right? These are opportunities that you could potentially embed that stuff in a macro behind the scenes and allow your users to have access to that functionality. Now, there's a couple of things I like about this from a guardrail perspective. One of them comes from the way we're calling the macro. So the earlier macros, what you were seeing is we were describing a transform at the top, and we were handing the entire template to our Lambda function. What you can see here is we're actually calling an intrinsic function called fntransform. And we're telling CloudFormation exactly where we want this macro to kick in, which means that what I receive on the back end in my Lambda function is not the whole template, it is just this little snippet, right? So we're not exposing other pieces. We're not exposing maybe complex user data or other things. We're just giving it what it needs to get the job done. So that's kind of a cool guardrail that you can put on the front side. The interesting thing, this is what it looks like on, this is just basically, we're telling this macro that we've got this string, and we want to perform an operation of uppercase on it, right? And this is all stuff that I, as the macro designer, or this person as the macro designer, has sort of selected. So they've decided that they're going to have this operation field, and this is what it means to my macro, okay? And so what that allows you to do on the back side is put guardrails around the execution code as well. So I'm not accepting arbitrary code at this point. I've decided exactly what I want to expose, and what I want to expose are these particular Pythonic string manipulation functions, uppercase, lowercase, title caps, whatever it is. And then my code simply executes within the context of those guardrails. This is a little bit more abstracted. I've taken some of the code out, but you can see on the inside it's really just a very basic conditional statement. Right? But this is something that is just not inherent to CloudFormation at all. But with this macro, now every single template that I execute, I have access to these particular functions. Okay, moving on to a more complex example. This is something I'm still kind of chewing on, but something that I hear customers say is lacking from CloudFormation is a concept of sort of a global variable space. Right? So CloudFormation doesn't really have this space where you can just store a bunch of values and request them arbitrarily. We have parameters, so you can actually receive inputs, and we have mechanisms for retrieving values from a resource that's been created through fngetat. But this is sort of something that developers seem to miss a lot when they're writing CloudFormation. So someone has written a macro to sort of provide this. So essentially, you can sort of build a global namespace at the top of your template, and you can define strings there. You can define more complex objects. We've got some key value pairs here. And then we can take those and we can leverage those throughout the rest of our template. They've used the very clever prefix of @, right? Which is, interestingly enough, kind of showing how non-imperative CloudFormation is not overloading, right? We just don't use @. So that's an opportunity to sort of construct this additional namespace here. And you can kind of see what happens on the backside. This macro is aware when it's getting handed a string, when it's getting handed a more complex object, and it's able to inject those as appropriate based on needs. Where this might come in particularly useful, I know there are situations where you might need to pass to a resource like a JSON object, right? And CloudFormation parameters only handle strings. So this gives you that opportunity to sort of take that string and change it into whatever is actually needed for the underlying resource. So that's kind of another cool use case. Here's the code for that. Again, this has been abstracted a little bit, but you can kind of see one of the important things about this particular one, right, is remember that what we're receiving at the start of, at the top is going to be just this dictionary, sort of this large object with all of our template or whatever snippet it is. So you're going to have to think when you write a macro about, what exactly am I looking at? You're going to have to sort of do the appropriate identification. Is this a string? Is this a dict? Is this a list? And then be contextual about it. Now, what I suspect is going to happen, and what I hope is going to happen, is our fine friends in the community will hopefully take this, run with it, and we'll start to see some sort of pre-baked libraries that are going to be useful for this type of thing. I am already getting ideas for doing that. We do a lot of the same thing. If anyone's using the linter, obviously we have to do a lot of parsing of CloudFormation. And Kevin DeJong, who's kind of the lead developer on that, has written some really good helper functions that I think would be good for macros too. So stay tuned for that. Another one here is generating additional resources. So the concept here is we love our downstream users, but we don't always trust our downstream users, particularly in the enterprise, to always do the right thing. And so this was a macro that was written for an enterprise customer that essentially allows you to sort of make sure that the customer gets what they want, but they also sort of get what they should have done in the first place. So what this is doing is this macro has identified that there is an S3 bucket defined within this template. And it's going to be injecting in some additional properties for that bucket to make sure that there's an appropriate policy on that, private, right, as buckets should be. And then goes ahead and sort of expands out and adds a full-on bucket policy to that as well that's been predefined. Now, what I think is clever about this particular implementation, and again, this will be in the GitHub repo, is that they did not code all of that sort of those additional properties and stuffs into the macro itself. It actually reads that out of a file and sort of does a merge, right? So that's kind of another interesting use case here, is take what the end user said and then sort of overlay best practices on top of that. This one in particular has the ability to override, which is very developer friendly, right? So I can say, okay, this is typically what I want, but actually in this case I don't want it, so don't do it. If you were writing this from a governance perspective, you might not want that capability, right? It might be, no, this is actually how it has to be because we have a fiduciary responsibility to our downstream customers or something like that. Okay. So I think that's kind of it for the macro side of the fence. I'm going to hand off to Luis, and Luis is going to talk a little bit more about the imperative side of the fence.
Thank you, Chuck. Boy, there's really no grateful way to get off of that chair. Good afternoon. If you heard me talk before, this is not my natural speaking voice. I lost my voice yesterday, but I'll find it. So, all right, so a couple of comments on macros that I want to add. Some of these examples perhaps are not realistic in a production environment, like executing Python arbitrarily, but I'll say two things. Number one, you can always change your Python macro code to restrict people and do things like clean up the code and check it. But the idea here is to give you a sense of a balance of how powerful these macros can be while making the example simple enough so that you can see, oh, this might apply to something I want to do. It can do transformations. It can create levels of abstraction so that one of the important parts about this is that notice that the templates that you use the transformations don't have to be any more complicated other than calling the macro. So you can strike a balance between adding more functionality to the language while your template users, not necessarily the coders, can gain that benefit without knowing a higher level language. Speaking of that, let's talk about imperative programming and CloudFormation. So Chuck mentioned before the CDK. With the CDK and with other programming languages, not only can you, if you're used to not only programming in TypeScript, JavaScript, Node, and if you're used to creating really good unit tests for that, you have the opportunity to program infrastructure for CloudFormation while also adding traditional unit testing for those things. But it goes beyond that, because you can use object-oriented principles to say, I'm going to create components, and inside of these components, we're going to have multiple resources in those components, and I'll show you a sample of that. What that does, at the end of the day, it's improve the productivity of the developer, and those components can be easily reused by other CDK users. As he also mentioned, for Python users, I happen to be a big fan of Python and Troposphere. It's a very mature project, generates both YAML and JSON. They leverage our resource specification, which means that every time that we add support for a new attribute or for a new resource, that automatically gets inherited by Troposphere. So if you have Troposphere code, you'll be able to use recently released support as soon as it gets released. And that can be very powerful. Ruby users can leverage SPARQL formation. And also for macros, Ruby users can now use Lambda, because earlier this week we announced that now Ruby users can create Lambda functions as well. SPARQL formation is used by a lot of people as well. And see, this is one of the benefits with working with CloudFormation. We have so many users of so many backgrounds that both operational type programmers create features and they open source them and add to a very rich ecosystem. At the same time, we have very expert users that also do the same and contribute to open source as well. All the tools that I mentioned here are still generating YAML and JSON code so that you can take advantage of CloudFormation's ability to do rollbacks, to manage state, and to, in many cases, automatically check dependencies for you. The diagram here just illustrates that in CDK in particular, you can start with resources, group those resources into components, and then just program components inside of a stack. That stack can be combined with other stacks, and you can just package an entire environment in one CDK package. And then you can package applications that way. How does CDK work? You download it, you get a bunch of utilities, and you get a bunch of models already pre-made for you, not only for typical use cases, but modules that, for example, if you're doing serverless, much like the serverless transform will do in CloudFormation, where it kind of like creates stuff for you, the same thing applies to CDK. So it sets up your project, you get a whole bunch of models already baked in, you add to those models, you compile it, that generates CloudFormation templates, and it goes even further than that. It manages your stacks behind the scenes, manages your deploys, so CloudFormation becomes the processor of that model. Before I go any further, while we're talking about CDK and macros, both of these were released a couple of months ago. For my curiosity, have any of you already tried to kick the tires on macros yet? One person, okay. Two people. You hesitated, you were kind of like thinking about it. No, yeah, I used it. Okay. How many people have seen CDK before? Okay. Any of you? Oh, there's one. There's two. Okay. So 2 and 2. Perfect. So let me show you what happens when you install and kind of like run through a basic CDK example.
And one thing, oh, is it started?
Yeah.
Go ahead.
You install it from NPM, and then once installed, installs very quickly, you initiate an app. It's designed to eventually support many languages as well. Once the app is initialized, you build it, and it builds the stacks and everything. It deploys it, and as you see the events coming back, they're going to look very familiar. They look like CloudFormation events. Deploys very quickly, and completes. Then let's go and change one line of code here, because this will give you the power of the components. I have a new SNS topic, and I'm going to go out there and add a queue. And that's all I need to write there. That generates actually 2 CloudFormation resources behind the scenes. How do we know that? We build it again, and then we do a diff from that version that we've deployed to this version. So that line of code added a queue policy and an SNS subscription. So again, it's about programmer efficiency, programmer productivity, do a lot of things with the least amount of work. You deploy the update, stack gets updated. Diff, everything looks good. So CDK is pretty powerful. Now, I do understand that for many CloudFormation customers, the reason why they use something like YAML or JSON and everything is because they're not necessarily SDK programmers. So that should not be a detriment to the fact that coding in YAML and troubleshooting coding YAML in many cases can be a lot faster because there's a lot less code to maintain. So saying that one is better than the other, I like people to more think about there's use cases for both. And remember, in many cases, your CloudFormation users don't necessarily want to know the details of your template and everything. You might be using CloudFormation behind the scenes if you're using Beanstalk or Service Catalog or another AWS product. In fact, many third-party products as well use CloudFormation behind the scenes. So you should be open to doing declarative, doing imperative, and doing perhaps a mix of both.
The one sort of other point I wanted to make about the CDK before we move forward is it is in developer preview right now. And so it is sort of in its early days, but the team is very, very, very receptive to your thoughts about it and where it would be useful for them to go next. So this is a great opportunity to kind of dig in at an early stage and sort of help us understand what that should look like going forward.
Absolutely. That's an excellent point. One of the things that I concentrated a lot on when I joined CloudFormation 2 years ago is that we can do so much more to improve developer productivity. And these are just a few examples. Not only you got CDK, you got the linter that my colleague here, Chuck, maintains. And you'll see us putting even more projects in open source, not only because it's a good idea to actually help back the community, but because it engages more users and it really truly makes the product better for everybody else. So you'll see a lot of that. Now, the reason why I bring this slide on SDK here is that we're talking about CDK and everything. And if you're a typical CloudFormation user, you don't have to worry about the SDK that's behind the scenes. But basically, if you're an SDK user, you'll put yourself in a really good position to also learn CDK. As most of you know, there's 3 primary ways to operate AWS. Using the browser-based consoles, which are still a very valid way to do your operations, doing CLI commands, or operating the APIs, and that's where you use SDK. For Python, for example, our Python SDK is Boto. The latest version is Boto 3. And Boto is used by Troposphere. As Chuck mentioned before, Troposphere is you program in Python, you can do testing in Python, generate JSON or YAML, and then execute CloudFormation. Troposphere code can be very simplistic, or it can be very complex. And in a way, just like I showed with CDK, you can create modules in Troposphere where one module may generate 3 or 4 other resources as well. But rather than talk about it, let's take our life into our own hands and try to do a demo. All right. Okay, take my life in my own hands. You guys are going to be safe. This is not going to hurt you a bit. How many of you have seen Cloud9 before? Okay, so this is not going to look strange at all. Excellent. So one of the benefits of using Cloud9, especially for Python developers, but also applying to Node developers, is that a lot of the things that we require are baked in for you. Cloud9 runs in an EC2 environment, and it comes pre-installed with the AWS CLI and with SDK and Boto components. So what I'm doing here to show you how Troposphere works is I have a Cloud9 machine with the standard software that you would get. You can get this as literally going and working in about 2 minutes. I'm going to show you how to execute a sample Python program here, because obviously Troposphere requires Boto, which in turn requires Python. So we're not going to win any design awards with this program, but we're still going to run it. Python. There you go. So a hello world program works. We can move on to something more clever. This is using Boto 3, which is the Python SDK for AWS. And in this simple program, as you can see, and you'll see this in most SDK programs, where you essentially create a client for the particular resource that you're using. And in this program, I'm going to run it, and it's going to list my existing S3 buckets. Don't judge me, because I really do create a lot of S3 buckets. I do a lot of demos. It's going to list my buckets, then I'm going to create a new bucket and run the list again to demonstrate that my bucket is there. And then it's going to delete my bucket and show the list again. All right, so let's see. And let's come up with a neat bucket name. That sounds like a good bucket name. And we're going to pick a region to use. All right. And it's done running. I'm going to try to maximize this to show you the result. There we go. So my old buckets now are all those. Try not to read too much into that garbage. I created a new bucket name. I can't believe I lost my voice. And my buckets now are, we're looking for one that starts with an I. There it is. I can't believe I lost my voice. Then we're going to go ahead and delete it. And my bucket, I lost my bucket. All right. So now let's show you how Troposphere works. So in this particular Troposphere code, what I'm going to try to do is use Troposphere to implement a iterator. So I can generate 3 different EC2 instances. So I'm going to import template, and I'm going to import only the sublibrary EC2 because that's all I'm going to use. And here, I'm going to have a couple of environments. We're going to have dev, test, and let's create a new environment for this, like acceptance, or accept, I guess. And then we're going to go through that array, and we're just going to create new names for the instances. And then we're going to go ahead and open a template file that has a heading and everything, and just generate YAML. So I'll go ahead and save this. All changes saved. Should be done. So let's open it up. And as you can see, the brand new one is here. There's one resource. There's my other resource. There's my other resource. And they're all generated just by this program. Turn around, take this template, upload it, or use a CLI, and it becomes a new CloudFormation stack. So in these very Bobby basic cases, super powerful, super easy to use. But what I would like to make you think about is that you can create a lot of really clever, very complex cases. You can use abstraction, and also, because you're now dealing in a language that's very well supported in IDEs, you can use its facilities to do things like automate unit tests, for example. So that's Cloud9 and Troposphere. So let's wrap up. As I've hinted a couple of times already, you can use declarative programming, you can use imperative programming, you can use both. Macros, in a way, are a good way to continue to use declarative programming, but expand enough of the functionality of CloudFormation with transforms, with ways to add more logic to your templates, and still allow most of the remaining of the CloudFormation users that may not know anything about Python or Lambda to still get the benefits of those things without having to jump into declarative coding. There are many macro possibilities. We designed these so that you get a sense of its power and also simple enough so that you can kind of like understand what it's trying to do. But I can tell you, for example, when we released this, I want to say it was like maybe 4 months ago. We announced it like in the middle of the afternoon, and within a couple of hours, there was already an AWS independent GitHub repository with people contributing macros already. So it's become very popular. I myself have seen now a little bit over 50 CloudFormation macros, and they can do some really powerful things like cloning resources, setting up with only a few lines, global DynamoDB tables, generating pipelines from a macro. So I strongly encourage you to, if nothing else, look at the examples. I think that you'll find that either for your pipelines or for your security groups, they'll find some really good uses for these things. But if you are a full stack developer or are not afraid to learn a language like Python or Ruby or JavaScript, you should consider using some imperative programming to create CloudFormation stuff. And again, because there's so many users of CloudFormation, we have so many options now. We're adding CDK as an option, which we mentioned before. Troposphere is an existing option that is very mature. There's many additional languages and specific language options, as we discussed. And you still leverage the CloudFormation benefits because you still generate YAML and JSON code. And with that, we'd like to thank you, and we hope that you continue to use CloudFormation.